I'm Andrew Duva, and I'll be moderating this Policy Forum panel this morning. I want to thank the MEDB and the Secure World Foundation for the invite and allowing me to come to, I believe it's my 6th AMOS Conference. It's a wonderful place to learn things and meet new people and get the pulse of how we're dealing with SSA and related matters. This morning's Policy Forum brings together experts in space situational awareness, flight dynamics, space debris, and satellite design, launch, and operations. Today, we will consider issues related to space sustainability given the advent of planned large constellations and lower barriers to access to space. An estimated 16,000 new satellites are planned for launch over the next decade, with multiple companies planning constellations of several hundred to thousands of satellites each. Civil and academic operators are also proliferating. Access to space is easier than ever before, but its reliable use may no longer be assured, particularly in the long term. We're well past the days where the big sky theory applies. Yes, they call it space for a reason, but it's not unlimited, particularly in certain Earth orbits, and we suffer from a real risk of a tragedy of the commons problem where a small number of irresponsible or unlucky actors may jeopardize sustainability for us all. Further complicating the issues, Doug Lavero told us yesterday that conflict will surely extend to space, and those in national security space roles acknowledge that the security environment is undergoing a period of dynamic change. For 7 years, we've been told that space is increasingly congested, contested, and competitive. These are the vaunted 3 C's of the U.S. national space policy. Policy folks love language, and we love words, and we love to define things. So let me suggest that civil and commercial space users might also consider applying a different set of 3 C's as they consider sustainability. And those are communicate, coordinate, and collaborate. For decades, civil and commercial space operators have valued their ability to act independently in space. This was okay. It was a fairly small club of nations and operators. As an international regulatory lawyer, I can attest that, given the high stakes involved, the actual national regulatory burden has varied from modest to nearly non-existent. And few national authorities were genuinely concerned or thought much about their potential derivative liability for the actions or inactions of their authorized commercial and civil actors. This is changing rapidly. So how can we think about sustainability? Let me offer one approach, which I'll admit is incomplete, and perhaps we can build together from there. So I have the privilege of having helped create and maintain the Space Data Association, or SDA. It's a nonprofit space traffic management and data sharing provider to hundreds of satellites and dozens of operators. But at its core, SDA is about sustainability. SDA has an overarching aim, which is enshrined in our organizational documents, our contracts, our supplier relationship, and that is to maintain what we call safety of flight. And that's shared by the responsible stewards of space who comprise its members. So how does SDA define safety of flight? This is from 2009. Safety of flight means the condition where satellites are positioned and operated in a manner that preserves their long-term operational viability, the long-term operational viability of any other satellites, and the preservation of the orbital regimes involved. That's how SDA thinks about safety of flight, which is really just saying, do well and keep the environment available for future use. So that safety of flight definition implies that space actors are responsible and will apply the 3 C's of communicating their information, coordinating their operations when in possible conflict, and collaborating through best practice sharing to make things better. Tomorrow's Policy Forum will consider international perspectives on the future of space traffic management. So today, we'll try to keep the focus on the hallmarks of promoting sustainability and not primarily on space traffic management. We've got a great panel, and what we'll do is we'll hear from each of them, and then for this session to succeed, we need you to participate. There's a website, which we'll put up on the screen, for questions. I'll receive those questions, and the panelists will field and answer them. But we really need your participation. You're not going to hear long presentations and then go to the break. You're going to hear some very provocative and interesting perspectives from each of the panelists, and then we would like to have a dialogue with you. We're going to go in order, and I'm going to sit down and listen. But our first speaker, and I'll introduce the speakers one after the other. Our first speaker is going to be Diana McKissick. Diana works for the 18th Space Control Squadron. If you operate a satellite, you probably know who she is. Part of the 21st Space Wing at Vandenberg Air Force Base. And she is the lead for space situational awareness sharing. And that's a very important thing. So, Diana, over to you.
Okay, great. So thank you for the introduction. It's a pleasure to be here. As Andrew said, most of you in the room know me. If you don't operate a satellite, you've probably submitted an orbital data request, and that comes through me too. So I would love to take the opportunity actually to make everybody understand, or help everyone understand, who the 18th Space Control Squadron is. So most of you actually might know us as the JSPOC. That's the organization we were under previously. But last summer, leadership decided to kind of separate our function away from the JSPOC so that we could provide or focus on foundational SSA, and the JSPOC could focus on theater support, and other organizations could focus on space defense. So now our primary mission is to provide that foundational SSA, not only for the US government, but also for the global space community. So I'm sure everyone in here is familiar with spacetrack.org. Almost all of the data that's on that website comes from the 18th Space Control Squadron. So what is foundational SSA? For us, it's a combination of maintaining the space catalog and also providing spaceflight safety services. So the catalog maintenance function includes three, primary activities: tracking, identifying, and detecting. And we do that for all man-made objects on orbit within our current capabilities. All of that data feeds into spaceflight safety services, which really include things from the full life cycle of a satellite. So launch collision avoidance, launch support, early orbit determination and identification, on-orbit conjunction assessment, collision avoidance, controlled deorbit support, and also uncontrolled reentry predictions. So at any given time, we're doing all of those functions for all active spacecraft. And so that's another incredibly unique portion of our mission, is that we are directed to provide all of these services for every operator of an active spacecraft. So it doesn't matter what country they're from, it doesn't matter if they're commercial, academic, government, this is what we do. So you can imagine that because we have this diverse customer base or operator community, it presents a lot of unique challenges through that life cycle. Specifically, small objects, tracking, discrimination, identification, accurate data on small, sparsely tracked objects to support collision avoidance, and support to plan the orbits to deconflict with the ISS so that we make sure that we maintain safety of human spaceflight. So to take it in relation to large constellations, which is why we're here today, I'm going to caveat everything I say with the fact that I've been very openly accused of being an optimist. So I am generally not at all worried about large constellations because I don't think they're necessarily presenting new problems. I think they're just increasing the magnitude of existing problems. And I was telling our German colleagues the other day, I would much rather deal with one operator who operates 4,000 satellites than 4,000 operators who operate one satellite. Because at least we can establish a working relationship and transparency to provide the support needed to negotiate issues. So how do we address these challenges? Well, certainly the US government needs to expand our data set. I think we've talked about that in a lot of different areas. And we can do this through fielding new capabilities like the space fence or leveraging our commercial and international partnerships. We also need to improve our data fusion I think coming to these conferences is fantastic because you see all of the amazing analysis and progress that's being made, but I think it's fusing all of that to actually support the wider community. And then, of course, I think the DoD needs to get better at supporting automation so that operators can make time-critical decisions. But I also think there's a lot of things operators can do. So even though I think there's a lot of overall concern about large constellations, I think this is an amazing opportunity, not just for the US government to improve our capability, but for operators to prove that they can actually set the standards for the wider community. So satellite operators can, I think first and foremost, build reliable spacecraft. They should certainly build in a maneuver capability so that they can do collision avoidance. And they need a solid deorbit plan that allows them to come down in a time that's relative to their operational mission. And above all else, I know it sounds incredibly basic, but just being transparent and communicative about your plans, I think goes so far in the space community to alleviate concerns and actually risk when you're finally doing your operations. So despite, I think, all of these concerns and challenges, I think we're moving into a very exciting time in space where we can actually prove that as a community, we can make things work, and it's not necessarily a threat to the overall space environment.
Okay, thank you, Diana. That's very thought-provoking. We're getting questions, but I'm going to keep collecting them, and we'll go through all the panelists and then have a dialogue. So next up will be Dr. Tim Floor. Dr. Floor is a space debris analyst and co-leads the space surveillance and tracking segment in the European Space Agency's Space Situational Awareness Program. Tim.
Yeah, thank you, Andrew. First of all, I would cordially like to thank you all, the organizers of this great conference, for inviting me to participate to this panel. And I'm extremely happy to be here and feel very honored that I can sit here with my colleagues at this panel. But to give my thoughts on large constellations, and I share Diana being an optimist, despite working on the debris topics for 20 years or so, I would like to mention that the free access to space, to our near Earth environment, is a very precious resource. We should all make use of this great resource, and by that meeting all the very different needs that we see today. So space is, for all of us, fascinating and makes many things easier, affordable, or simply possible. And as it has been voiced already, we are facing an enormous and historical step change in how we access space and how we utilize this unique and precious resource. So that said, we are responsible to use space carefully and to keep it protected for next generations. So big words. And by progressing further and now getting more to Earth by earning some money in exploiting space, we shall not forget that there is a need to manage the risk of rendering space unavailable. For a few years now, the launch statistics that we do have shown that the commercial and imaging satellites are now the highest contributor to space traffic. I think this is interesting. And despite that, we have also seen now statistics about 10 fragmentation events per year. Also in recent years, and also from recently launched new objects. And we can say that from the statistic, there are various anomalies that have happened, and also propulsion systems leading these fragmentations. So, and going further in that, when looking at the implementation of mitigation measures, in general, we see that for objects in LEO, in particular for those higher than 650 kilometers, there is a stagnation in the level of compliance with mitigation rules. When we look at successful post-mission disposal, then we remain at a very low level of about 5% if you're higher than 650 kilometers. That said, in GEO, trends are much more promising. So what I would like to say and outline is that we need a progress towards the self-commitment of spacefarers to space debris mitigation. That could be a charter, that could be guidelines, it could be whatever, but in any case it must be in line with the existing standards. We should cover operational practicalities and technical implementation issues, and we all shall take a special view on the issues connected with small missions and large constellations. So we already see large constellations before we see large constellations being deployed, we see already that the number of tracked objects in orbit grows faster than the number of operational satellites in orbit. Also interesting to note. And this has led to a corresponding increase in the threat to active missions from possible hypervelocity collisions, and that putting in jeopardy the crucial service that we all benefit from. So in some future scenarios that we analyzed with our environment evolution models, we have reached a tipping point such that collisions will increase in frequency even in the absence of new launches. So that means this is the Fiat-Kessler syndrome that we all try to avoid. So that shows that mitigation measures are required in order to limit the growth and to preserve space for the spacefarer of the future. And we have made some progress in the last years. We have a consensus in the IADC, which is the Interagency Space Coordination Committee, which issued these guidelines for mitigation 15 years ago, in 2002. And the UN endorsed these guidelines in 2008 with a title that is International Cooperation in the Peaceful Use of Outer Space. And then there is related ISO standards, 24113, that is there since 2011. And some countries or national regulatory frameworks have made reference to these UN, IADC, or ISO documents. Okay, that's great, that's progress. But who thought 15 years ago, when this all started, about small satellites and about large constellations? And who expected that this traffic goes to 1,000 kilometer altitude? So this is a step change not only in traffic, it's a step change also in use of altitude. And please keep in mind, if you do something at 1,000 kilometer altitude, your orbital lifetime is nearly eternal. So we need to think and speak about active disposal at the end of mission. So in the existing guidelines that we have are independent of the mission type, they're independent of the satellite size, and the consensus that we had with these major space agencies some 15 years ago is that the propagation of these mitigation standards into national standards and in regulation aspects is a valuable achievement, but is also a stable baseline that we should consider. So the main elements of the guidelines, just to mention this, is limit release of objects, prevent breakups, dispose at the end of mission, limit the casualty expectation upon re-entry, and perform collision avoidance. So, and overall in LEO we have now 60% compliance with this, and this is stable, and that's not good. So there is no success criteria reflecting the tolerable likelihood of technical failures. And the recent studies that we did have shown that negative environmental consequences of failures are significantly more severe compared to the average space traffic. That means that a very low number of space actors building and operating large constellations have to accept that they have a very high responsibility if we want these guidelines to remain valid and functional in the future. And to meet this responsibility, there are several ways, and we can talk about this later on, in which the constellation and the spacecraft design, and as well the operations concept, can help. And there we need to progress. So the key message that I have is that the recent studies have shown that the reliability of the post-mission disposal is the key driver for our sustainable use of the environment. So it is also essential that long-term robustness tests of the satellites we are going in these large constellations are required before the deployment of a full constellation. And that applies not only to satellites, but also to launch vehicles that we use. Post-mission disposal, passivation, and then also controlled re-entry of launch vehicles should be considered. All in all, my message is, once again, we are not necessarily lacking more guidelines and concepts for mitigation, but we need means and ways to better adhere to the existing guidelines. Thanks.
Thank you, Tim. Okay, next let's hear from Cyrus Foster. Cyrus leads the flight dynamics activities at Planet Labs, Inc., which is a large constellation operator. It's an imaging and analytics company operating a fleet of small satellites in LEO. His responsibilities include orbit determination, differential drag control, conjunction avoidance, and pre-launch analysis. Cyrus.
All right, thank you, Andrew. And I do have one slide I wanted to show, but so Planet is a data analytics company, and our mission is to take global imagery to the planet every day and make that accessible. We currently operate about 200 satellites in LEO. So we have a fleet of 5 rapid-eye satellites that have about 5-meter imaging resolution on the planet, and they operate at about 600-kilometer altitude orbit. We also currently have 7 SkySats. They'll be joined by 6 more in a month. And they operate mostly at around 500-kilometer altitude, and they get sub-meter resolution on the ground. And then finally, we have almost 200 Doves currently in orbit. They're very small spacecraft, and most of them are about 500 kilometers as well. In fact, we shared launches in the past between the Doves and the SkySats. There are a few Doves up at 600 kilometers, and there's a couple dozen that were deployed from the space station, and so they're below 400-kilometer altitude. Our collision avoidance strategy first involves launching low, and we've been lucky that we have a commercial mission, where the optimal orbit is one that is low, and so the optimal orbit for the commercial mission is also the optimal orbit from a conjunction avoidance point of view. Since we're imaging the planet, the closer we are to the planet, the more resolution we get. So we actually want to be as low as possible, just from a commercial mission point of view, but not too low, such that we have some decent orbital lifetime. So it turns out the sweet spot for us is about a 500-kilometer orbit, where the orbital lifetime is about 4 to 5 years. And then for the Doves that are on the high end, one of our first launches was up at 600 kilometers. Orbital lifetime there is still under 25 years, so we can comply with all the disposal requirements. We're also very open about sharing data from the satellites. So every hour, we're continuously performing orbit determination fits across the fleet, given the GPS data or ranging data that we have from the satellites. And then we're creating 10-day ephemeris predictions, and then we're sharing that with people like JSPOC, Space Data Association, and we're also just publishing it online, as well as correlation results between our satellites and JSPOC CAT IDs. And then finally, we have a conjunction response procedure. The Rapid Eye and SkySats, they have propulsion, they're very maneuverable satellites. The Doves do not have propulsion. They're very small spacecraft, but they do have a very large ratio between ballistic coefficients when they're in a very low drag or high drag mode. And we can use differential drag to some extent for maneuvering, and that's what we've been actively doing and successfully doing for phasing the constellations after launch into an equally spaced line scanner. And then another part of that is also using as much data as we can to inform us about these conjunction events and assessing the probabilities of collision, the missed distances, and anything relevant to taking action. So we've been working with Leo Labs, for example, for once we know we have a CDM and we know it may be pretty close, we can task them to acquire radar data and use that to refine our estimates of the secondary object. We know where our satellite is fairly well, given GPS data, but we don't always know where the secondary object is. And then the last point I wanted to add is also with regards to launch, not just launching low, but when you're deploying a lot of satellites all at once, it's coordinating how that deployment happens such that it happens in a very safe way. For example, earlier this year, our biggest launch was when we launched 88 of the Doves, and on that mission there were 100 CubeSats in total. And we're able to work directly with the launch provider, the PSLV, to figure out a strategy for how we want to deploy every single satellite such that they're all equally spaced in a long track delta V, such that they're all spreading out as quickly as possible. and minimize any chance of recontact between the satellites, so that we just get them off and away, without any risk. Yeah, and that's all I have.
Okay, thank you, Cyrus. So that's one responsible operator's approach to sustainable operations. Next up, we have Gary Henry, who is the Director of Satellite Systems within Phantom Works. That's a division of Boeing Defense, Space, and Security. He leads a team that's connecting the world by transitioning research and development programs into advanced mission capabilities for both terrestrial and space applications for the U.S. Department of Defense and the U.S. intelligence community. Before joining Boeing, Gary had a long and distinguished career in the Air Force, ending as a Colonel Henry. So, Gary?
Hey, good morning, everyone. Very much appreciate the opportunity to have a conversation with you this morning. For those of you who were at the Boeing Hospitality Suite at 2 a.m. this morning, it's nice to see you here. And in fact, I won't claim, well, anyway, I'm here, all right? And hopefully we can have a lucid conversation. So a couple things that I wanted to probably do for you this morning is just put some facts and data on the table with regards to a few things that Boeing is doing that is germane to the proliferation of large constellations. I think the second thing I'd like to do is probably tag onto some of the comments that Doug Lavero made yesterday about a contested space environment and how that, I think, might be germane to the discussions this morning, and then maybe a thought or two on the role launch may play. So getting to the first point with regards to constellations. So earlier this month, I think it was 11 September, SES and Boeing made an announcement with regards to a 7-constellation MEO a ComSat capability that is going to be launched in 2021. That's they call it O3B. O3B means other 3 billion, so that gives you a sense of the magnitude of the investment associated with some of these constellations that we see. But clearly, you start to see the migration from GeoSatcom to MEO as a very useful and lucrative mission space for these SATCOM providers. The other one I just thought I would draw your attention to, and I'm sure most of you are probably aware of it, is back in June of 2016, Boeing made a filing with the FCC for a constellation of between 1,400 and 3,000 satellites operating in V-band with about 5 gigahertz of bandwidth. What I found was interesting is 1,200 kilometer orbit. We had talked about the relevance of 1,200 kilometers. At least it's a good choice for the moment. And I just thought I'd share with you the first 400 satellites are programmed to operate in 35 planes at 45 degrees inclination, and then 6 planes at 55 degrees. And then the remainder of the constellation, when it flies, is a total of 12 additional planes at 55 degrees, and then 21 planes at 88 degrees inclination. So you kind of get a sense of what this would look like. What I also thought was interesting when I reviewed the filing is they talked about the disposal piece. So about 90% of its propulsion is dedicated to disposal. So these satellites operating between 1,000 and 1,200 kilometers will lower to below 500 kilometers, and then of course comply with a 25-year disposal requirement that we're asked to adhere to. And it also had, interestingly, some attributes to deal with debris. So there were actually artifacts on the satellite that were intended to deal with V-bar type, potential V-bar collisions and whatnot to enhance the overall life of the vehicle. Clearly, I think the signals are clear and unambiguous, right? These large constellations are going to happen. They're going to happen probably sooner than we would have imagined 5 years ago, and I think the trend is irrevocable. And the one thing I would ask is, I suspect that since I brought these two things up, there's at least one person in the room that's going to ask all kinds of questions about either one of those. just so you know, I've given you all I'm allowed to say today about both of those. So if you get any of those questions, just delete them. All right. The second thing I just thought I would discuss briefly is okay. So what does a contested space environment mean for all of us, especially commercial SATCOM, commercial space enterprise writ large, and what does it mean with regards to maintaining safety of flight and really kind of helping us preserve and fortify future commerce in space. So for those of us that have been in the SSA world for a while, one of the aspiring attributes of the network was, when are we going to get to machine interactions and optimization of the SSN to deal with the mission space that we've got to go and tackle? That's going to happen sooner than you think now. It's no longer a conversation about if we're going to do that. It's going to happen. If I were a betting person, I would say by 2025, it's a certainty. I think there's a legitimate case for some significant capability and trends in that direction by 2020. And the reason for that is, again, it's being driven by the contested space imperative that the United States government and other governments are coming to grips with. And there's nothing like things like that to motivate behaviors. So I thought about that, and I said, well, what's the consequence for the discussions we're having here? Well, clearly, we're going to kind of take the SSN to a new level of performance, both with regards to productivity as well as a capability. There will be new sensors, both terrestrial and space, that will be coming online. And really the question, I think, for Space Command, the U.S. government, is what do we do with that, right? I mean, there's a lot of value there with regards to orbital safety and really kind of promoting the commercial part of this. And that's the TBD part, right? I think that'll be an evolving conversation that we will have at future AMOS conferences, but I think it will be a relevant one, and I think we're going to find it's going to happen fairly quickly. And then the last thing that I would just like to mention is, in my previous life, I did spend some time in the launch world, and we were discussing last night, when we were kind of getting our thoughts together for this presentation. Launch vehicles are one of the biggest contributors to debris today, and there are a lot of very good actors out there that really work very aggressively to make design changes in their launch vehicles to minimize debris. Now, arguably debris, SV-SEP and LEO, okay, that kind of debris isn't going to last very long. But clearly things for these MEO-GEO missions, there's debris produced that isn't going away for a very long time. And so really, launch vehicle providers need to be part of this conversation. And that was one thought I had. The other one was, wouldn't it be interesting, for the purposes of trying to create a control point for debris generation in the future, you actually leverage your launch vehicle providers to help enforce it? Of course, they're not going to come along willingly, but if you think about it, they do have a lot of influence with regards to the behaviors of their payloads. And I think that there's a potential there to create some incentives, and they could be monetary, for our launch vehicle providers to help enforce that kind of behaviors on the part of these actors. So anyway, that's really some of the thoughts I had up until now, and I look forward to your questions. Thank you.
Okay, thanks, Gary. Well, we are getting questions, and I remind the audience that you should go to the website and continue to submit questions. We have about a half an hour left, and I think we will use all of it based on what I'm seeing. So let's start with the easy ones. So this will go to Diane. This is an easy one. It's a clarification. So what do you mean by deorbit within a time frame relative to mission duration?
Is this on? Okay. What we see is, and I think Tim can talk to us quite a bit, with the 25-year orbital debris mitigation guidelines, quite often, a satellite will launch and their operational mission is maybe months, but they can reside on orbit for years. And we, at the 18th, dedicate resources to tracking those objects. We would prefer to allocate those resources to active spacecraft as well as non-cooperative spacecraft. So as a community, bringing those down in a more relevant amount of time really helps us do our mission better.
Okay, so does that suggest that having a deorbiting capability or a way to accelerate the deorbit schedule should be a precursor to access to space?
We would like that. But then again, we're the DoD, so we can't make those rules. So I would actually invite the rest of the crowd here.
Any other thoughts?
No, maybe.
I think just speak.
Maybe I can, yeah. Of course, the 25-year rule that we have in most of the guidelines and regulations is for all the satellites in LEO. But of course, it does not mean if you, by easy changes, can shorten it. You have the right to stay there as much as you want. You should not aim at arriving at 25 years, if this answers part of your question. But one thing I would like to add here is if you put some effort in going down, let's say in 5 years, and you compromise this by the reliability of doing your post-mission disposal, that's not what we want. Yeah? If you ask me what is more favorable, going down in 25 years guaranteed with 100% reliability or in 5 years with 80%, then I mean my answer would be go down with a higher reliability out of the orbit. It's not that if you go down in 5 years instead of 25 years, you're doing 5 times better. It's just to get out of the orbit. That's what we are after.
So we're looking for certainty if we can find it.
Exactly. Yeah.
Okay, well that's a good lead into questions for Gary. 2 questions related, I think. One is, have you given any thought to paying for a service to remove your own satellites that might fail in their ops orbit? And 2, how can you be sure that your satellites won't fail at this it's a large number.
Let me try to tackle the first one first. And just to make sure I answer it succinctly, could you just repeat the
first one?
The first one.
Yeah. Have you given any thought to paying for a service to remove your own satellites that might fail in their operational orbit?
So I actually think there is an opportunity for a service like that to become irrelevant. I've always felt that, and those who've had these conversations with me believe that clearly, launch vehicles are driven by the masses that we've got to put in these mission orbits, and that drives significant cost to the overall mission. I think there are solutions out there that are potentially sustainable for on-orbit orbital transfer vehicles that could, ultimately start to ubiquitously move payloads here and there. And if you close that mission, if you close that business case, then clearly that is a service you could provide, right? Where, hey, when it comes to on-orbit disposal, we'll take care of you, right? For a salvage fee or for some I think very affordable at a very affordable cost. So would Boeing be open to that? Certainly. I mean, I think anybody would. If you think about the mass that propulsive deorbit, those solutions drive you to, I think you could make that construct close very early, easily in the construct I described of again a service, right? That allows you to move payloads, LEO, MEO, GEO, and beyond. And the second question, just to do that due diligence as well, could you repeat that for me?
Sure. How will you ensure that none of your satellites will fail? That there are no design faults?
Boeing, it's magical pixie dust, all right, and it seems to work. It seems to work with reasonable success. So, yeah, we could spend hours talking about that. Really, I think what that's really kind of starting to poke at. What's the sweet spot, right, for for lives for mean mission durations and whatnot of constellations going forward. And I don't think there's a single answer. I think that based upon I find what you're doing at Planet Labs fascinating, right? And clearly you're not designing for a 15-year mission life, right? So it's really situationally dependent. I think the reality is we're going to find that there's going to be a proliferation of vehicles that live anywhere from 3 months to 15 years, and we still see market space, and we see mission and requirement space driving us to very long life vehicles. But clearly the trend is to shorter ones, and of course all that stuff's going to become debris at some point, right? So.
Okay. So this could be we have an inevitable regulatory question, and I'm going to read the question and then add to it. Assuming corporations will act to limit debris in their own interests, how much regulation is needed, and how much is enough? And I want the panel to also think about not just corporations, but others that might access space, for example, academic users. Are we at the right level of regulation today, or is more needed?
I mean, I'll tackle maybe one aspect of that is, so currently when a satellite operator in the US, when they want to get a license to launch, they have to go through, or at least we have to go through the FCC and NOAA, because we're also Earth imaging, and for both these license requests, we have to submit an ODAR, orbit debris assessment report. And in that report, we have to specify, amongst other things, what is the anticipated orbital lifetime, what's the disposal plan, and also quantify what is the probability of a collision over the lifetime of the satellite. But there's no requirement in that plan for what is your conjunction mitigation strategy, or at least detailed, what data you're going to use, how are you going to compute how are you going to make a decision, and what criteria you're going to use to make a decision. So maybe getting operators just to specify what they're going to do and have a plan for that could be something we could have in the licensing process for that.
Okay. So that's so the U.S. has come one of the high water marks, I think, for regulation, as I survey the international scenes. But let's go to Europe. I mean, Tim, how does ESA encourage good action from operators? What is ESA specifically doing in its multinational role to either compel or encourage good outcomes?
Yeah. You're right, we are intergovernmental, so we are speaking for a large part of Europe. There are several things that can be done, and a few points have been mentioned by my colleagues here. One is, I think the most important one, to communicate, and that also goes to the previous question. If you manage to reach out for all these small satellite, cube satellite operators, designers, and make them aware of the issue, it's already a big step. I think Diana shares my view that you cannot know everybody building a satellite today. And when you know about these satellites, when they are in orbit, it's probably too late to discuss design measures. Or operational practices are then limited to what you have in orbit. So what we are doing at ESA specifically, we have made software and models, and these are available to the world. So we have a environment model, and we have then a tool suite using this environment model master. That the tool is called Drama, and that can be used to assess in the design process how effective you are in your design measures, and how what you could change. And then we do training, we do outreach, we go out and reach to universities, being a technology-driven organization. This is easy, so we have young folks coming to us, we're supporting small satellite designers with all that. And that's the one side. And the other side is we work with other agencies. We work on the mitigation guidelines. We work in the IEDC. We are very active there. We are on all the working groups. We are chairing and working groups. And we participate in these long-term environment predictions where we compare how good are we in the future and what we are doing today. So it's the nice exercise trying to predict the future in view of this very much changing launch traffic ahead of us. So these are two things, and we hope that the combination of both is sufficient to make the existing guidelines sufficient for the future challenges.
Okay, those are great policy, education, and outreach initiatives. Let me ask a follow-up that's come in for you, Tim. Is ESA prepared to support the international community in tracking the increased number of objects, especially in emergency situations? So it's more of an operational focused question.
Of course. I mean, we are not operating a space surveillance network. Not that you missed it, but no, we don't. Okay. We have, however, a few systems available that are sensors, in particular on the optical domain, that can support such activities, and we have done these things. So we have supported and worked together with other operators. We worked with Diana and colleagues in exchanging data. We have a data sharing agreement, we use that, but we also can work directly with operators. There's no worries, you can contact us. Yeah.
Okay, thanks. Well, the sensors is an interesting topic. Yesterday, the panel, we had a lot of sensor and data providers up on stage, and they spoke about their business models and how that market's developing. So we've got a question here. I think it's for everyone. It's provocative. What are the panel's thoughts on the comments from yesterday relating to the impact on the commercial sector from the Air Force providing free services?
I'll start.
Okay.
So I think I mentioned it in my opening remarks, we have an incredibly diverse space community. When I started this job in 2010, we were tracking, 890 active satellites, 100 organizations possibly. And those were very much your Iridiums, your SES, your Intelsats, the old school operators, I think is the way they're referred to. Now we support well over 300 organizations, and I think, thanks to Planet, we're up to 1,800 some active satellites, which is good on you. You did a good job. So, and I'm glad we have a cooperative partner that we're working with as the number of active satellites increase. But I think it's very important to have a free baseline of spaceflight safety data. I think there is so much potential in the commercial sector to build on top of that. I am the first person to say that the DoD, we provide spaceflight safety data. We do not provide advanced analysis. We don't provide maneuver notifications, or I should say recommendations or optimized plans. And there is such a role for the commercial sector to do that. I think Planet has a great business model in the fact that they're leveraging commercial capabilities to build on what we provide as a baseline for every operator. And I think that's very important to spaceflight safety.
Other perspectives?
Yeah, as a satellite operator, I'd say it is of interest to us to know about, where the space debris is. I mean, we know where our satellites are, but when we get a conjunction data message and it looks like it may be close, there is a need to get, and it is desirable to get a lot more data, tracking data on that secondary object so we know where it is. JSPOC is not meant to, track everybody's conjunction, when there is a high alert and gets extra data for them. But on a per need basis, it's of interest for us to know where that secondary is so we can make a more informed decision about whether a maneuver is warranted or not. And then, if in a commercial market for radar data or tracking data, if there is an expanded catalog, say down to the 2 centimeter object level, and all of a sudden we see all these potential conjunctions that we didn't see before, we'd like to know about that. We'd like to make maneuver decisions based on these 2 centimeter objects too, because they could and produce a collision in pretty much the same way that a 10 centimeter or larger object could. So I'd say, it's of interest for us to get more data on secondaries, to see more objects that might be out there. So I think there is definitely room for a commercial market there.
All right.
Just a quick thought. So I honestly believe, and I've actually been educated by the conversations we've been having with this panel and being here, that I think it's in the U.S. government's national interest, and I believe it's in the broader community's interest to have a sustainable, viable capability to provide safety of flight, right, for everyone. I think that needs to be a ubiquitous service provided. I do think, though, for those out there that are trying to find a business model that works, the regulatory construct that precipitates out of this capability as it goes forward is going to be really important. Because, I mean, if you think to the extreme, given where the U.S. government needs to go with regards to the scenario I talked about before, that's going to create a lot of data that is very relevant to safety of flight. But it also, if not parlayed correctly, could discourage some new starts to provide what would be very valuable service. So I think we're going to need to think through this really, really carefully. And I would just add, if you don't think the debris is going to be important to the warfighter, trust me, there's adversaries that are masquerading as debris, right? They just do. So that data is going to be there. It's just not clear how it's going to be used, and I have no answers for that. But it'll be there.
Okay. There's several questions coming in about what I'll call business arrangements. So I'll read a couple of these. A couple innovative ideas here. Should spacecraft owners pay a financial deposit for each kilogram placed into orbit that could be paid to a company retrieving or mitigating the eventual debris? Another observation, ISS payload and the payloads have many conjunctions with non-maneuverable CubeSats. Should the ISS and other owner-operators maintain the burden for those avoidance maneuvers? And yeah, with the recent breakup events at GEO, how does operator responsibility come into play with degrading the environment? The sort of broad responsibility questions and allocation of risk and cost. Any thoughts on that?
I can just start with the ISS question. So, like, if you look at the Planet Labs doves, most of them at 500 kilometers, so we're below most space debris. We look at distribution of number of objects by altitude. Most debris is, in the 700 to maybe 1,000 kilometer range. So we start out below that population, and then we're just dropping down and eventually re-entering in 4 or 5 years. But we're one of the large notable assets below us that we will cross is the International Space Station. So we've been working with the folks at the Johnson Space Center who manage the space station maneuvers and providing them data, not just about where the doves are right now, but also forecasts on the distribution of the doves in the years to come. And they've been calculating, what is the increased probability that they would have to make a maneuver to avoid a unacceptable misdistance with a dove. And it turns out it's something like, I don't want to speak for them, but it was something about 1% more likely they would have to make a maneuver given the dove population that we have now. So that crossing the space station is something we're aware of. They're in different orbital planes, but they still have common nodes. But I feel like the risk can be mitigated, and it's not. It's more or less the noise of the number of non-operational satellites or debris objects that are crossing the space station as it is now.
Anyone else want to?
Yeah, on the topic of responsibility in general, I just wanted to echo, I think, some of Tim's comments in that I think responsibility really starts when you're developing a spacecraft. And that's one of, I think, our bigger challenges at the 18th. It's not a formal part of spaceflight safety, but we try to engage early with operators before they launch. Because a lot of responsibility, I think, happens when you're designing your mission plan, when you're selecting a launch provider, when you're deciding what your satellite should do and for how long. And all of that influences, I think, the safety after that. So I think it's our collective responsibility as a community to actually enable that early planning. And it's a challenge for the DoD because it's not our formal role, but I'm glad Tim was able to explain everything ESA's doing to kind of support the community in those efforts.
I may go, thanks Diana, I may go back to the question on whether to pay for, because I cannot answer it, that's why I have to say something. If you enter into this, I fear that you open a huge box of questions that follow on that. Because first thing is, what is your legal framework for that? And so that's why I can't answer it, I'm not a lawyer. Next question derived would be, what is the data that you base your decisions on to decide whether somebody has to pay or not? Mm-hmm. Does it make the data provider also accountable or not? I mean, that's just, I'm thinking ahead of this question, what it means if you go into this direction. So that's why I think, I cannot answer it, but I think it's a long discussion needed.
Well, the follow-on, as a lawyer, I'll jump in, but this follow-on question, which is I think the broad one, which is should national launch licensing authorities consider space traffic management in their decision process? Should they approve constellations they're incapable of overseeing?
I think we should save that question for tomorrow.
I was going to say, that might be a nice segue for tomorrow's question. I'll tell you what, I don't know how many regulators are in the audience. I know FAA's here from the US. I'm not sure how many others are here, but that's a great question. There's a bunch, we're running out of time here, so there's a bunch of questions relating, essentially, I think that's really all SSN and US government related about, let me just try to summarize, how good will the space fence be? What kind of detection criteria will it have? How much of that catalog will be released? Why is it taking so long to have machine-to-machine interfaces for the SSN? From a commercial perspective, it's taking so long. How can we accelerate it? And a bunch of others. Do you want to say anything about capability, advancement?
I think all I can say in my position, because as the 18th, we're a tactical unit, so we receive the data, we use it. We're not involved necessarily in the ConOps development of what the space fence will do. I certainly know the intent is to detect much smaller objects without the need to specifically task, which will alleviate a lot of our other resources to do very more specific things. Unfortunately, I can't say much more than that, just because it's, as you can imagine, this is reflective of the whole SSA enterprise and not necessarily what's just happening at the 18th.
Okay. Anyone else want to venture an opinion?
I'm repeating myself, but this is a really hard question, right? So clearly, the existing SSN and the future SSN will be tracking some very small objects, right? And so I guess if the rubric was, hey, nothing useful can be done under 10 centimeters, so we'll just report all of it, right? Because it must be debris, right? If that were true, then maybe you could come up with a rationale for detection of anything below 10 centimeters, just being readily available for safety of flight reasons. Unfortunately, that's probably not true. All right, so what do you do? So the U.S. government, they're going to be able to help us, the world writ large, I think, make some substantial inroads in safety of flight, which is very relevant to where we're headed. But I honestly don't think anybody in this room or really anybody on the planet knows yet how we're going to tackle that. But it just seems like that there's probably some protocols that we can put in place to expose data that is consistent with national defense as well as the greater good. And I think that's still TBD.
Yeah, it seems with the proliferation of sensor providers and data processors, we've seen some of them on stage yesterday, it may not be a decision that's within the ambit of solely of the United States for much longer. So we'll see. Let me wrap up with one quick question on standardization. I've got a couple questions on whether data types are being standardized. When we talk about exchanging this kind of information, are we where we need to be with regard to standardizing data types and communication methods, or do we have ways to go there?
Yeah, probably I can give a quick answer. There is a lot of progress recently made. One example that most of you probably know is CDMs, Conjunction Data Messages, that I think in the CCSDS, that was the forum standardizing it, it's still the fastest standardization or message process that they ever had, because there was so much pressure and interest from the community. And I think this is something to be kept in mind also for the future little needs that we still have for data exchange in SSA. If there is interest and people stepping in, it goes much faster and it can be a huge success. And there is I can tell you a lot of things going on already, but we first also have to understand the architecture of the future SSA data sharing, how it looks like. But at the technical level, we are quite far, I have to say.
All right, and I think we are out of time. So, audience, please join me in thanking our panelists.